Okay, I am sharing my screen. Can you see my screen?
Yes, Doc.
Yes, we can see it.
Yes, we can see the screen.
Wow, well, I didn't know that it does this. Okay, so the course is, I think it's EMBL509, isn't it? Management
Indeed,
Information
Doc.
Systems. My name is Benny Nyambo. I'll share with you the course outline. Basically, this course, I just adapted it from a course from University of Manitoba in Canada by a guy called Dr. Bob Trifica. I just enjoyed the way he did his course. He created, I think he wrote a book on it and created notes on it. And so I just thought, well, I adapt what he has been doing, and it appeared very clear to me. So basically, most of the content I'm going to give you is from that course, from this guy. So you can always find his website and see what he's doing. I think he has a current course running right now, the same course. But anyway, would like to look at the focus, the course at a glance, and we'll discuss what's in the assignments. Basically, management information systems is an area of management studied in practice, just like marketing, human resources management, and so forth. And MIS focuses on managing organizational information systems in order to improve organization and achieve greater efficiency, productivity, and effectiveness. That is basically achievement of goals of an organization. And the central concept of information systems, the central concept is actually information systems, which include data, information technology, and work procedures. So the term MIS is basically historical and was created when the main kind of information systems was called MIS. It recorded transactions and reported on basic operations like payroll, inventory, and sales. So today, MIS is about any type of information systems. So basically, our course, we're still calling it MIS, but we could just call it information systems. And they insisted that we call it managing information systems and e-commerce. But basically, for you to have e-commerce, you're actually using an information system. So basically, e-commerce, well, it fits hand in glove in information systems. So basically, MBL509 is an introductory course. We're not going to be going deeper like people who are actually doing a degree of information systems. Want you to have a feel of what it means in terms of information systems and how do information systems relate to business processes, as you guys have got a lot of experience and training in business. So we'll be looking at management approach taken focusing on business. So business basically is an organization and processes. So you're talking of business processes. Main goals of this course is basically to understand organizational data in various states of an organization. Then business processes working with this data, and how information systems do support business processes, and how information systems can support, how information system support can actually be improved. Guys, can someone accept the people in the lobby? Johnny? Then we have to look at critical thinking, which is basically not a magic stick. And we need to understand that new technology solves some problems, but not all of them. So I will share the course outline and all study materials through Google Drive. So basically, the emails you have sent me, I'll use them to share content with you on Google Drive so that you can download at your own time. And I'm going to create, as you have requested, I'm going to create videos maybe at my own time and pace, and also share with you on Google Drive. And the videos, maybe I can even put them on YouTube so that you can actually watch them anytime and anywhere. So there's a lot of study materials I'm going to give you. You are free to ask me for more content. There are people in the lobby. Okay, no one is in the lobby. If they gone out?
I was checking, I did not see anyone.
Okay. So our mutual expectations that I expect that you do your study related work the best you can for a high grade, all right, given your time constraints and goals. I know that it's not easy, you're going to work and so forth, and the COVID situations make us not be able to meet. And you have to, but you have to do your best in your coursework. We're going to have basically three assignments. Yeah, we're going to have 3 assignments. And the first one is data in data analysis and diagramming. And the second one is in business process analysis and diagramming. And the third one is in e-commerce and information system security. This time around, I think I will have to give you these assignments in good time, so that those who are capable of reading fast, they can actually write these assignments and submit in good time. I expect people to work together, but not to copy each other. I may actually subject the assignments to anti-plagiarism software to see if you did copy from someone else. And also, I don't expect you to copy and paste from the internet. I expect you to write work and if you take someone's work from the internet, I expect you to cite it. I know you know these things, you are not new to it. Okay, so the information we are dealing with, the content is, there's a lot of content, but of course, we know we'll handle it. Now we want to go straight into the content. You're still seeing my screen, isn't it?
Yes, we can see it, Doctor.
Yes, Doc, it's clear.
All right. Now, we'll have to look at the basic concepts. Here, we want to look at data, knowledge, and information. And then data, knowledge, information in organizations. Then we are going to look at information system user, information technologies in this first lecture here. Now, I'd like to ask you, is this information the first bullet? Answer me, guys.
Yes, Doc, to me, it might be information depending on the people, how they understand the language which was used. But to me, when I'm seeing it, it's not information because I don't understand the language which has been used there. I'm just seeing some funny.
Hieroglyphics.
Yes.
Okay. Yes. And what about the second one?
The second is information, sir.
The second one is information. Right. Okay. So we want to look at data, then we go to information. Data basically are symbols created by people for communication purposes. So we have voices, letters, numbers, pictures, even videos. You realize now we are communicating through a video, so which means there's a lot of data passing by. Data are organized at different levels. Where we are talking, let's say letters go to words, text, and even a report. And data quantity can actually be precisely measured in bits, bytes, kilobytes, and so forth, megabytes, gigabytes, terabytes. I don't know after tera what do we get, zettabytes, and so forth. So information quantity is harder to assess because basically information is what is basically the meaning, isn't it? So we can't quantify a meaning or something. Maybe we can quantify its importance, that is important or not important, but not in terms of bytes or bits. So information systems help to organize and transform data into sorted text, tabulated numbers, structured reports, etc. So basically from a process perspective, information is a result of interpreting data by using knowledge. So basically you have data and you have knowledge. So if you have that data and put your knowledge on top of that data, then you can actually extract information from there. So that's why the first tab, you said it's not information because your knowledge is limiting you on what it means. So oral information refers to data that are understood by a person. You realize that data basically is taken in as a plural. That's why we say are. I know that in Zimbabwe mostly we say data is, isn't it? Data is expensive. Data is what? But in the actual sense, it's as a plural. So data, if you have data, and if you have knowledge to understand the meaning of the data, then you have information, right? So understanding data refers to grasping a meaning of data, which happens in the human brain. So information is the meaning of data. So if you look at this diagram here, on the left, we have a computer which delivers a sales report. So if Majoni is a manager and he gets this sales report, he has knowledge as a manager of the language to read the text, numbers, graphs in the sales report. And he knows concepts of customer, purchase, time, salesperson, how these relate to each other, what part of the report to look at, and so forth, and all that other complicated stuff you guys do. So the manager understands that from that report, customer number 18 spent about $300 in one purchase, which is the largest sale last month. So that becomes information. So you have that data and the information that our largest sale was from customer 18 who spent $300 in one purchase. So basically, so we had data and we converted into information by use of knowledge. So basically, the term information is overused today. It comes as a handy choice for any content. So this causes confusion in communication, as it is not clear what exactly different people mean by information. So someone will just say this is information, and someone say maybe this is just data, and so forth. So, but that's not too much of an issue in this course. We're not going to ask you to define, is this information, is this data? This is just but an introduction to what we want to delve into. Are you able to do that? Knowledge. Knowledge basically comes from complex structures in our brain or in our human memory. So basically, knowledge implies understanding what something is. So you're talking of concepts, relationships, taxonomies, and so forth, or why something is the way it is, which is the cause-effect relationship between concepts. Or knowledge can be actually how to do something, which is procedures and experience. So knowledge can be represented in talk, books, information systems, and other forms. So pictorially, you can actually have a data, knowledge, and information in a picture like this, where you have your knowledge working on the data for you to get information. When you get information, that information, it actually advances your knowledge. You have more knowledge. From that more knowledge, you can even work on more data, and cyclically, you can actually create more information. So knowledge uses data to create information. That is, it enables interpreting of data to grasp the meaning of it. And the new information advances the knowledge. So most work in modern organizations is about data, knowledge, and information. And occupational groups like managers, professionals, and clerks work in different aspects of these three. So you have clerks, basically, clerks works mostly on data. So which means you have your clerks or secretaries, some of these people, they just enter information, data entry clerks and so forth. Or even a person at a team, these people, they're just entering information. I mean entering data. Then managers, they interpret data in reports and elsewhere to get informed for managing. And all other professionals use the knowledge they have to analyze or resolve professional problems and advance their knowledge. So what is basically systems or information systems? Any system is a set of related parts with a common purpose to produce some outputs from inputs. So we have different systems for different purposes, depending on the output you want to produce. So a purpose of an educational system is to produce a graduate, isn't it? So the purpose of an information system is to organize and transform data for system users. So basically, here we're talking of a system. What is a system? A general system. Now, how do we relate it to an information system? So basically, you can only talk of a system when you know its purpose. So the purpose of an information system is to take data which comes into an information system and transform it for the benefit of its users. So in general, we can actually have a definition where we can say an information system is a system that outputs transformed and organized data for informing the user. And a computer-based information system is a whole that consists of one, data, two, computer hardware and software, which we may call information technologies, and procedures applied to data, which is software and hardware. So you have your data coming in, maybe through your keyboard, mouse, and whatever you're going to do. And then you're going to store that data in the systems. And you can actually use procedures to interpret or convert that data. And you can actually screen it out so that other people can actually see what's happening. So the output is actually a transformed and organized data. So basically, data is at the heart of an information systems. So input data is different from output data. So you put in data. Let's say if you think of someone who's working in a bank, you put in data. Someone actually putting in money, depositing, and someone is just typing in. And then you can actually have a report, which is maybe your transactions report and so forth. So you can actually print your, say I want to print my statement and see all the outputs. So the data which is on the statement is different from the data which you entered. You entered once at a time, but in the statement you can actually bring out that, so you can actually know what was the balance then and so forth and so forth. So an information system user is a person that uses an information system by manipulating it or by interpreting its output. So sometimes you have people who just put in the data and people who actually read the data. So all of them, they are users. So if a primary user who direct use manipulates data and IT, and the secondary user whose indirect use interprets and outputted data. So many higher level managers are secondary users of information systems, because many higher managers, they want to see the data which is interpreted. They want to look at reports. So they are actually secondary users. And data clerks and other people who actually manipulate the system are primary users. And IT basically are machines and devices for managing the data. So a machine works on its own and may perform multiple functions. For example, a computer or a smartphone. Sorry, hello? Yes, sorry, in dream lecture. Hello, I'm in a lecture, may you call me in an hour? So it can actually also be a device that works under control of people and machines and performs usually a single function. So basically, we know that IT, there are lots of IT instruments which we know, cell phones, computers, storage devices, and so forth. And we use these tools together with an information system. So basically, we have to see the difference between IT and information system. Usually, the information system are the softwares which work on the computer systems or in the IT. So the IT are that's just machines which actually handle or manipulate the systems. So basically, when you are talking of systems, here we are talking of HR systems, accounting systems, and so forth. So if you see a computer, you can't say this is an HR system. That's just your information technology. But the system is the software which is used. So in summary, you can actually say data are symbols created by people for communication purposes, and data can be recorded in various ways. And knowledge is complex structures in human memory that make a person understand what something is, why something is like what it is, and how to do something. Knowledge is in human brain and it can be represented in complex data structures. Information is the data that are understood by people, or the meaning of the data. So there is no understanding of data without knowledge. Information is created in human brain, although people often assume that external data is already information. So in organizations, clerks mostly deal with data, managers with information, and professionals with knowledge. So any system is a whole made of related parts with common purpose to produce some output and inputs. So systems are differentiated depending on the outputs. That is their purpose. So the purpose of information systems is to store, organize, and transform input data. And computer-based information system is a world that consists of data, computer hardware, and software, and procedures applied to data, software, and hardware. And data are the heart of information systems. So system procedures are often work procedures, the way tasks and jobs are done. So this is the first class of basically relating to information, to data, knowledge, and information. So as we said, data is at the heart of information systems. So the next few slides will actually be talking on data. Do you have any questions, comrades?
No questions right now. No questions right now.
Okay,
Yeah,
thank you.
We are following, Doc. We are following.
All right. So in this third class, we want to talk about data in business. And if I'm going too fast, guys, so things can get crazy. So mukanza munhu ati ngindi movement admit anditika because I won't be seeing that person when the lecture is going on. Can you help me with that, guys?
Doc, it seems like most of the guys who are in the lobby are just probably there is a network issue of some sort.
Okay.
If you admit them, they are not getting into the meeting, into the lecture. They will keep on, coming in and out. So I don't know what could be the issue.
Yeah, it's the issue of network. I think you are right. Okay. Zvino munhu unongoramba uri kuvhuranda asingapinde mumba. All right. So here I want to talk about in this one, you guys, I expect you to pay particular attention. I'll go slowly on this one a little bit, especially at the end and the next lecture. Here I want to talk about business and data, paper and electronic data formats, information system and organizational culture, information systems and electronic database, and then electronic relational database, data management systems, and structured query language. My experience from the past years, in past semesters, that the next two slides, people don't really like them very much because I move very quickly from talking general terms and becomes a little bit technical. So most people don't want to be technical, but don't panic. You understand the concepts as we go. If you don't, please stop me, I can explain further. All right. Now, every business deals with data. So if you look at that diagram, we actually have a lot of data sources in an organization, and there's data comes from business documentation, professional documentation, and communication. So there are many sources where data comes from in an organization. Now, paper trail. Paper trail is a popular term for all organizational data stored on paper. So here we are talking of notes, correspondence, forms, and files. So we really see people always say, follow the paper trail. This word is usually, I think auditors are the ones who actually enjoy this one. Paper has been used for a long time, and many people and organizations are still used to it. It's difficult to shake off, and it's going to persist for a long time. And paper is more secure, but hard to access, search, and transfer. So basically, we are saying it's difficult for someone to change, or it's easy to secure papers because you just put them in a room and lock them up. And that data is secure and you are happy, and you put a security guard at the door. Unlike in computers, people are worried that if I put my information there, will I be able to get it out? If I transfer my money to this person, will the money get there? And so forth. But if you want to search for information in papers, information which is stored in a paper format, it may take you a very long time depending on the amount of paper which is there. So it's hard to access, search, and transfer. I can ask you to imagine the people who are actually trying to write Bibles from scrolls. So they had to write with their hands and so forth on paper here and there before the advent of computers or even the typewriter. Searching for information. I remember very long back, I lost my, I wanted to change my birth certificate from being a short birth certificate, the small one, to a big one. So I went to the Registrar General's office, and at that time they were still searching. So they had to go through, inside there are many shelves, and they had to search for my file. They couldn't find it. Eventually they found my sisters for them to take information from my parents, which, on the long birth certificate, there's lots of information, your parents' name and so forth. So searching paper is not easy. And if you want to transfer it to another paper, it's also not as easy. So here we're actually trying to compare paper and electronic data format, the pros and cons. So on the creation, paper data is actually manual, and electronic data, of course, there's manual entry. But from there, everything can actually become automatic, right? So the good thing about electronic data, if you are smart enough, there is only one entry. And from there on, we are just interpreting or processing the data. The searching of the data on the paper data is manual and slow. On the electronic data, it's automatic and fast. So you can actually just go even in a very big document, it says search for this word, and it searches, and it tells you that this word appears 40 times or things like that. Kevin says search and replace. Transfer. Of course, for paper data, it's slow. You have to do it manual again, just like creating or photocopying, but still is slow. And electronic data usually transfer is very fast. And space requirement for paper is very high. So which means the amount of paper which fills a very big room can actually, that data which is on papers and filling a room can actually be carried in your memory stick. So the space requirement for electronic data is extremely low. Mobility. Yeah, I always forget to read what they wanted to say about mobility. Maybe someone can come back and tell me what they were saying by paper mobility is high and mobility of electronic data is moderate and improving. I'm not so sure what mobility here is. I don't want to lie. Anyone who can understand what that mobility means? On security for paper data is location related. As we said, you can actually put it in a room and lock it up. But it can actually have some physical hazard, where especially fire and so forth, water damage, things like that. Those are some of the dangers of paper data. Or even someone can just come in and actually tear up your papers. Or you can do it by mistake. Especially as you can see, auditors and you knew that you were doing something wrong and you start shredding papers. All of a sudden you realize that you have shredded your O-level certificate. And we are in trouble. But on the security side, it's harder to falsify the paper data. On the electronic data, on the security, there's always a risk of network access, where someone in Russia can just access your computer right now, or even my computer right now, and stop our lecture. Can you imagine? And there is also still physical hazard, but not as big as the, yeah, but yes, there's a physical hazard, because if there's a fire, if there is water in a room, computers can be damaged or things like that. So yes, physical hazard is there. And electronic devices, you can actually one day, and you can just see your memory stick is no longer functioning, but it was full of data. So there's a physical hazard there that it's no longer functioning and you are in trouble. And on integrity of the data, electronic data can actually be falsified. So you can actually see a lot of people changing information, saying this is mine, taking some other people's information and say this is mine. This is why sometimes we're actually now in academia, we are saying we are using anti-plagiarism software to see the work we are submitting, is it really yours, comrade? Or you just copied and pasted? Because the transfer of information, electronic data is very fast. It just takes seconds. Copy, paste, and you are done. You want to get an A, first class, and we'll catch you. So, but the issue of falsification is actually a problem. Preservation. Yes, preservation of paper data is a long term. So that's an advantage of paper. But on electronic data, sometimes you can lose data here and there, especially when the devices stop working. So you have to migrate to new technology with the data. So if you look at long back people in banks, I saw someone in this class who works at FBC. Whose name is that? In the banks long back, we used to have data on magnetic tapes.
My name is Lazarus.
Yes, Laz. You say?
Tiri right say.
Yopo wakatanga kusenza mbank kuchine magnetic tape wakambaone.
Yes, sir.
Saka kudhara mune magnetic tape muchinawe.
Zvichashandi zvaisimbozoshandiswa as backup, but now akusisina zvinhu izvozvo.
Okay.
Yes, sir.
So basically, so that's what we're saying. Because you know, data repa magnetic tape, you can actually lose it. Magnetic tape. So now They are actually migrating to new technology. And of course, every technology has got its own disadvantage. But we're trying to come up with more and more new technology, which is more secure. So in overall, electronic format overcomes disadvantages of paper and can meet its advantages and keep improving. All right. So that cylinder here is the electronic, and those are the papers on your right. So basically, we're trying to say electronic format is trying to replace paper. We are talking of paperless office. I know the people, especially in the banks, you have realized that people in the banks, they're saying now when you get there, they don't want to handle a lot of paper. Please bring your card. You want to withdraw money, now they say don't fill in those papers, you just swipe, then we'll give you your money. Use your mobile app to do transactions. If you want to transfer money to someone else, just use your mobile app. Internet banking, things like that, your Zipit and your RTGS. So they are trying to actually come up with what they call paperless offices. In many organizations, they're trying to do that, and there are a lot of advantages on that. But the paper sometimes it resists, yeah? It resists the older generations, government, and other people, other offices usually they want to have. You know what I'm saying? So if eventually maybe you do a lot of other work electronically, but when it comes to the big boss, you have to print it and he wants to sign it, and you come back with the signed paper and you scan it. So paper is resisting, but we hope that in future it's going to be more and less and less paper in the offices. It saves a lot of money. You know, it's expensive to buy a bond paper, cartridge, and printers usually they just die and you have to buy new ones. So there's always an expense with paper and the storage of the paper. You know, in this COVID era, there's danger of transmission of the virus through paper. So it's always easy or always better to go electronic. Here at the, you know, I work at the Zimbabwe Open University. We're trying to move to electronic examinations, online examinations. We hope that will be successful because this paper thing is the old way of doing things, and we hope it will die a natural death. So organizational culture refers to deep, stable beliefs and accustomed practice shared by employees in an organization. So if the culture is saying we use paper, the paper will persist, but we hope that that culture is usually changing. So in other organizations, if your CEO is very young, you can actually see that you move very quickly towards electronic paper. Or if your CEO is a tech savvy, you move towards a paperless office as quickly as possible. So that culture needs to change and change fast. Now, when you're talking of information systems and electronic databases, we have different views of information systems. You have your user interface, which is the connection between the user and the information system. So which means when you are using a system, log in there, you have a login page, you do one or two things, you save, things like that. But there is also functionality or the back end of the system. When you are saying you're saving to what? Where is the data going? When you are interacting with the system, what are you interacting with? So that's the functionality of the system. So if you look at this diagram, if this is the information system, you have your user interface where everyone can enter in the data or access the data from the system. Then the functionality are the rules which actually govern what you're doing. That if you enter if you enter here where there's written name, it actually goes and puts the name in the database. All right, so that's the functionality. So here where you have DB, that's the database. The database is actually where you store data, electronic data. And the database actually sits, it's a software, so it actually sits on the computer hardware and software. So it actually sits in the operating system and the operating system in the hardware. Okay. So the database is the storage of data and it's actually a foundation of the information systems. So there is no information system without database in the background. So we have to appreciate this, that we are talking of, when you are talking of an information system, the central thing which we talk about is called a database or a database. In our pronunciation is vakaranga, vashona, vakadya sadza nekukara. So a database is possible to search efficiently. So in a database, you can actually search information and be able to retrieve it efficiently and fast. Now these days we have what we call mobile information systems. We know we've been talking about your mobile app, mobile banking and so forth. I'm going to use banking as an example there. You have your phone there. It runs your softwares, and that phone you have your phone hardware, and it has its operating system. So most of our phones here have got Android operating system. If you are running your Huawei, your Samsung, and so forth. But if you have a Windows phone, it has a Windows operating system. If you have an Apple phone, it has an iOS operating system. So depending on the type of phone, it has a different operating system. So if you have your mobile app on your phone, your mobile app is the user interface at the top there, right? That's the interface. It actually gives you the interface. And your phone connects to the server, which is at your bank. And the server, it actually contains your functionality. It actually have a software which actually dictates how the system, the information system work. The relationship between if you enter information at the front and how does it come to the database. And then you have your database at the end there. This is where your data is coming to sit in. So your records are actually coming in to sit in the database, usually mostly as tables. So you have data being stored in tables. All right. So we will see later what we mean when we talk of data in tables. So your mobile app is not a whole information system, but just part of it. So if you have your mobile banking software there, it's just part of the system. In fact, the smallest part of the system, because it just gives you the access. It's like we are talking to the bank teller. So the bank teller is not the bank. He's just part of the big system. So basically, an electronic database is a collection of data that are organized so that they reflect business and meet technology requirements. An electronic database resembles a paper file cabinet in the data organization, but is much stronger on the search side. So if your company is still using a file cabinets, just imagine where you actually have your files in the cabinets and you can actually put in these things and you tag them, right? You take them A to Z and you put information for each, if this drawer is for employees, this drawer is for customers, this drawer is for what, and everything is put in alphabetical order or by date, I don't know. It's so that if someone comes in, they want to search for information, it becomes easy for them to search. One way of organizing data is in tables, as you studied in the, we're not going to do the lab, but we're just going to explain how it it relates. As I said, we don't want to make this a practical course. We want us to have an appreciation of what we are talking about. So that you guys, when you go back to your workplace and someone say the IT guys are saying database radona, which means basically there is no longer connection to the database, right? So which means they are saying my interface is not connecting to the database. So they have to actually sort one or two things to recreate that connection. So the database is dropped and you don't know what is dropping from where, right? It's just meaning that there is no longer connection between the user interface and the database. So sometimes they have to restart the database and now you can see it. Now we have what they call relational database. This is the most common type of database. This is the one we're going to talk about and we're going to study, but there are many other types of databases out there these days. And in relational databases, data are organized in tables. So the technical name for a table is a relation. So a table is a relation, which means you are putting information which is related in the same table. So that's why they call it a relational database. So tables reflect objects in business reality. So you can actually have a customer table, an order table, an employee table, things like that. Product table. Tables are connected to reflect, for the most part, associations between business objects. So if you are going to talk about customers and orders, so you have a table of customers and a table of orders. You can actually connect these two to relate to which customer have this order. Right, so that's an association. So we'll talk about these things. So when we start talking about these things, don't panic. I want you to appreciate it. Relational database is the basis for a transaction processing system. A transaction processing system and management information system. We're going to talk about this later in the course, but a transaction processing system is just a system where you can actually do transactions, where you guys, you pay your fees there, you pay your fees and the information gets in there. You can actually look at your account and you can interpret the data. What is my credit and so forth. Then you have management information systems where management can actually interpret information in these systems depending on what they are getting. We'll see these things later. I hope we have time to do that. So basically a table is like this. So you can actually have here, they are actually having a table as a secret agent. So when you read it, you actually see that there is a column for key, a column for agent name, a column for birth date. So you can actually see an agent, a key, 007, and the agent name is Bond, James Bond, and his date of birth is 5 May 1964, and 006 George Z, and his date of birth was June 1, 1980. So this is when, if you want to search to view the table, you will see this. But when we create, when we design it, we have what we call attributes and data types. So the attribute agent ID, which is coming in there as the key, and it has to be in data type here. It was given a number. Attribute for an agent is agent name, and the data type they put there is text for a name, like Bond, James Bond. And date of birth, the data type was a date. So which means when you are dealing with the databases and you're entering information, where it's written, enter new agent, and you want to put the agent ID, and you put a letter there, it will refuse because the data type is supposed to be a number. And if you put a letter, it refuses. And agent name, it's text, so you can write anything, where characters and numbers. And when we're talking of the date of birth, and you write something which is not a date of birth, then it will refuse. It will say, put in the right information there. So this is how you see it on the left, and on the right, it's how it was designed. We'll deal with these things as we go in the next lecture. And this is another example. We are saying a table is basically a collection of columns and rows. All right? And every column is an attribute. Every column gives an attribute. For example, customer number, right? And a row equals the set of attributes. A row, each row identified by an attribute that must have a unique value in each row, which is the key attribute. You have your primary key. So the primary key actually helps you identify something like your animal ID. So in this example, which is down there, it's a table of pet animals. So each animal has got an animal ID, which is the primary key. The primary key is actually there to uniquely identify an entity, right? So here, these are pets. So the first pet there with an animal ID 2, and it did not have a name, but it's a fish, and it's a breed angel, and there's a date there, and its gender. The next one is an animal ID 4, and it has the name Simon. It's a dog. That's its breed. I don't know, Vizsla. What type of a breed is that? Date, and it's male. So basically, just like that. So every pet there, you can actually call it an entity of a table. It's an entity of a table. And its name, category, breed, date of birth, gender, we call that an attribute. It's actually an attribute of that entity. You will meet these terms as you go forward. So this is another example The table at the top there is actually a supplier table. So this is, we're talking of a database of a company which sells some parts. All right, some parts. So at the top, the green table is a supplier table. So each supplier have got a unique supplier number, which is the primary key. So no one should get the key here, which has been given to someone else. You have your unique supplier number. The supplier name is not unique because if you think of your names and your name is John Piri, if you just go to Fakos right now, you come back with a John Piri. If you go to Tungwiza, you come back with another John Piri, but they are two different people. But if we're going to put them in our supplier list, it's better to give them numbers. It's a supplier number, which is unique. So you can't use their names. Then the supplier street, supplier city, supplier province, supplier, I'm not sure what PC is. All these are attributes of the suppliers. Then the parts, we've got a part table. The part table, each part have got a part number, which is the primary key. And then the part name, unit price, supplier number, all these are attributes of parts. What is important now is to see that the supplier number, each part is given a supplier number. Now the supplier number is no longer the primary key here. The supplier number is actually a foreign key, which is coming out from the supplier table. So we call that a foreign key. So the relationship between supplier and part is through the supplier number. So that's the relationship. So that's why we call up that this is a relational database. So there's a relationship between this table and that table. We'll see as we study in next lecture. So tables are linked via keys and foreign keys. And a primary key basically is the attribute that uniquely identifies each row in a table. And a foreign key is the attribute that is the key in another table. Just like the supplier number in the part table is a foreign key because it's a key from another table. Now we have what we call database management systems. A database management system is actually a software package for creating a database. So you will hear people talking of Microsoft Access, Oracle, SQL Server, MongoDB, and so forth. So these are softwares which you buy and you use these to create your own database. All right. So a database management system is just a software which you use to create a database. And an important component for the database management system is a search engine. So which means if you create a database, you may actually be able to search through the database using the search engine. So the search engine, it runs queries on the database to search and retrieve information you want to use. So you have a report writer also, which usually uses queries to create reports for users. So you see, in most cases, your manager can actually say, can you create a report for me showing me the sales this month, so that we can actually interpret. So use a report writer to do that. And we have access management. Access management actually gives access privileges, read, write, update, and so forth. So which means access management, you can actually, in a database, can actually set privileges, saying this person is only allowed to enter data. This person is only allowed to read but cannot enter data. This person is only allowed to see reports, cannot enter data. Things like that. Because multiple users access the database at the same time, but they do different things on the database. Usually, when you are creating the database, they use what they call structured query language. In short, SQL. We're not going to learn this. This just stating it for you to know that there is a structured query language which is used by people who create databases. We use these. They have syntax rules to do search, to create, and so forth. You can actually create a database, delete it, search through, and you can run many queries. And the queries like select, it lists desired columns from desired tables, from identified tables, where, and so forth. We're not going to do this because we're not doing information systems or computer science. If we're studying this, we would have done that. So this we're going to ignore. So in summary, business processes use data that are either in electronic or paper format. Paper is still useful. Paper is still useful, but we hope that as the culture changes, we're going to replace all the paper or the data on the paper with electronic databases. And we have relational databases, and they have primary keys and foreign keys. And a database management system is basically software which you use to create and retrieve data from a database. And the structured query language is the standard language which they use for database retrieval. Thank you very much. Any questions? Any questions, comrades?
Like what you indicated at the beginning, that this is more technical. Maybe we need again to really revisit after the lecture. Then from there we conceptualize and get more understanding.
Okay. Thank you, Mr. Majoni. Where do you work, Mr. Majoni?
Inini ndoshenza kuChiNo University of Technology.
Okay. Which system do you use at the invest system at CAT? Which system do you use?
We use IGU.
Can you come again?
We use the IGU.
IGU. What do you use IGU for?
IGU is the system ndio inoti managera ma results edu pa university.
All right, so it's a results management system.
Yes.
Are you a lecturer or a administrative stuff. Right. No, it's like I want to move from your point of view and try to explain what we've been learning right now.
Indeed.
Okay. Now we have Mr. Majon, who is a lecturer. And when he's teaching, he accesses Ego from his front end. That's the user interface where you can actually see the names of the students, places where you can actually enter assignment marks, in places where you can actually enter exam marks, isn't it?
Yes.
So when you enter that information goes into the database. Are we together?
Yes.
So in the database, that data now, we have tables where you can actually have a table maybe with names of students, a table with names of courses, and so forth. All right? And each student have got attributes in a table where you can actually say attributes of a student is maybe the student ID, which we know that is unique, isn't it? That's the primary key. Then we go in and say student name, address, phone number, next of kin, things like that. And the course ID, which has to be unique, the title of the course, the level, the lecturer, and so forth. And then you relate these things in that table. How to get?
Yes, sir.
So that's what we call we're talking about when you're talking of databases. If we're talking of people like Lazarus there, they have databases for the banking system where you have maybe your clients, customers, you have your client ID. So which means if you realize that you have an account number, each person you've got for each account, you are not more worried about the person, but you are worried about the account. So the account number is unique. Then from there, that's the primary key. We go in and say, what's the name of the person, the account name. So we can actually have a lot of Beninyambos in this world. But the one who is at FBC holding this account number, that's unique. That's the primary key. How to get? So when you are going to talk of attributes, you're talking of these attributes that you have a customer and they have the account number, their first name, their surname, their address, and so forth, phone number, all those things. Okay. I'm a little bit, I need some water. 5 minutes break, guys. Maybe we can log out and come back later after 10 minutes so that we can have a water break.
It's okay. It's okay.
Yeah, but log out say it may it may be difficult.
Okay, nandizoitira kuti data ranyinogora ramba rakadyika isi tisiri kushanda.
All right. Yeah, those who can who know that they will be able to come back. For me, I think I will leave it like that.
All right, 5 minutes, we'll be back.
It depends. Maybe vamwe vari kushandisa vari kuma-organizations avo vari kushandisa ma-Wi-Fi, if they can keep on hanging, I think that will not be a problem.
Okay, so those who are worried about data can log out, come back after 10 minutes. Now it's 3 past. At quarter past, we'll be back.
It's okay, sir. And
Okay, guys, I think we can start and continue. Is it okay?
Yes, we are in.
All right, so we are still dealing with, now want to look at data. So this is the guy which I said I'm adopting his lectures, and his course is called MIS 2000. His name is Bob Trifica. I think you can always find, when I share his content, you can always find his website. I now want to look at data analysis. Here I want to know how to create the diagrams, which we call data diagrams. So basically, data analysis implies looking at the world so that you recognize important objects that can be represented in an information system. Business objects are represented with appropriate data in databases as the heart of the information systems. So the data analysis can be graphically represented in diagrams. And data analysis and diagramming are essentially in many areas, for example, in supply chain, production, marketing, and human resources. And data analysis and diagramming is necessary to perform in order to design information systems. So in every process, data is used as well, created, stored, transformed, deleted, or transferred. So data diagrams represent this data. So here we want to study one of these diagrams. The one is called a schema or a tables diagram. So want to know how do we create a table? What we call a schema. So basically, the process, those who design databases, they go through this process and do these designs. So the components of a data diagram, basically it consists of an entity, attributes, association or relationship between tables, and multiplicity. Remember when we were saying we have a table of customers. So if you have a customer called John, that's the entity John in the table customers. And his attributes are his ID, his name, date of birth, phone number, and so forth. So basically, attributes explain or actually identify the person or describe the person. All right. Then association was saying we've got a table of customers in the table of orders. So in the order, the relationship between the customers and the orders tables, we call that an association or a relationship. Then multiplicity, we'll explain it more, but it's part of the relationship where one entity does something many times in another table. So what is an entity? Basically, an entity is a representation of some business object. For example, an object in business reality is a customer or a person. It is represented as an entity customer in a database. Okay, so which means we have an entity. When talking about entities, we use nouns. So entities can actually be persons, for example, a customer, student, employee, and so forth. or physical things in services. For example, tangible products like cars, services supplied like courses, and so forth. Even things like an account, you know, organizational units like university departments, an event like a purchase, a sale, a course registration. It can actually be an entity, or a concept, which is a student performance, employee profile, a purchase order, customer order, things like that. Specific examples of an entity are called instances. For example, a customer named John Jones is an instance of an entity customer. Okay? So which means if you've got a table for customers, we expect to see an instance where we have an entity John Jones. So that's an instance of an entity customer, John Jones. An attribute is a piece of data, an aspect of an entity. For example, a customer number, a customer name, customer address, telephone number, all are attributes of an entity customer. So when we have data for particular attributes, these data are called attribute values or just a value. For example, 21325 and John Jones are values of attribute customer number and customer name respectively. So when you're talking of attributes, we also use nouns. Of course, this can be confusing since entities are indicated in the same way. So to differentiate this, nouns standing for attributes from nouns standing for entities, remember that an attribute is actually a piece of an entity or a description of an entity or a characteristic of an entity. So which means a name, address, age, things like that. So therefore, an attribute cannot exist on its own, but just as part of an entity. So you cannot have an attribute of age. It should be age of someone, an age of an entity, or a date of birth of an entity, things like that. In contrast, an entity is a set of attributes and it exists on its own. Now we have, when you're talking of attributes, we have what we call primary key. A primary key is basically an attribute of particular importance. We can just call it a key. It is important because it identifies each individual instance of an entity. Maybe I should actually say it uniquely identifies. Because basically what we are saying is when we are talking of a primary key, we are saying we want that key to be used to uniquely identify the entity. If these are students, I have Majoni and Lazarus. If I give them student numbers, I know that these two guys will never share the same student number. So I think student number will become a primary key. for an entity table student. But sometimes a key can be a combination of attributes and not just a single attribute. We'll learn that more. When a primary key has some of its values repeated in instances of another entity, these values are called foreign keys. So a primary key appearing as an attribute in another table for another entity, we call that a foreign key. So both the key or the primary key and the foreign key are special attributes that have the role to establish what we call an association between tables. Association or a relationship. An association or a relationship represents a connection between entities. For example, a customer places an order. So the relationship here is that we have a customer table and an order table, but we know that a customer places an order. So the placing part is the relationship. So a relationship in a data diagram usually reflects a relationship between things in reality. So when talking about relationship, we use verbs since something performs some action on something else. Like places, it's a verb, it's a doing word. Right? You know, you guys are very familiar with verbs, eh? Kuita nekuitiswa. Kuitwa. Multiplicity. Multiplicity defines how many instances of related entities can participate in the relationship. For example, a customer might place many orders. So which means there's a multiplicity. We have one customer, but we have many orders. That's a multiplicity. And each order is placed by one particular customer. Right? In a data diagram, multiplicity is specified by numbers, for example, 1, 2, 3, and so forth. And sometimes letters. For example, M, meaning many, that is some quantity that varies, because you don't know, especially for orders, you don't know how many orders a customer can actually place. So you can actually just put M. Note that multiplicity is included for the sake of having a complete diagram. So here, let's look at this figure. The figure here is a diagram containing all the 4 components discussed: entities, attributes, relationship, primary keys, and multiplicities. And if you look at this, we have a customer entity and an order entity. The customer entity have got attributes: customer ID, last name, middle name, first name, address, city, province, postal code, phone. And the order have got an order number, customer ID, order date. Now, so which means here the entities are customer and order, and the attributes are listed inside each entity. So attribute is more like some characteristic of an entity. Now for customer, the customer ID is the primary key. And you have to see that the primary keys, when in a diagram, usually you write the customer key at the first attribute and underline it. For the order, it's actually the order number. it's interesting to note that customer ID also appears under order number. So under order number, under order entity, the customer ID is a foreign key. So it was a primary key in the customer ID, in the customer entity, but it's a foreign key in the order entity. And the relationship between customer and order is that a customer places orders. That's the relationship. And the multiplicity in the relationship says that one customer can place more or many orders. So that's why we have an M up there. All right. So this is a simplified diagram which have got two entities, customer and order, and each entity have got attributes. And under those attributes, one of the attributes should be a primary key. A primary key, as we said, it uniquely identifies an instance of an entity. So if you're going to have a customer, if I'm going to come to your company and become a customer, you have to give me an ID. And in your database, under customer table, my ID as customer ID will be the primary key, and it should uniquely identify me. If you say customer 1234 and you search in your database, it should bring information that this person is called Ben Nyambo, he lives there, and so forth. He was born in this date, and so forth, so forth, so forth. All right. So how do we develop? How do we draw these tables? So a data diagram basically reflects business. Therefore, a diagram creator has to understand the business. So that's the most important thing. You cannot just start drawing a diagram, a data diagram for a business which you don't understand. You have to appreciate the business so that you can actually now represent it. So this is very important because the data diagram is going to be used to develop the database, and the database is the core part of the information system. So sometimes we see people, we buy software to use in our business, and at the end of the day, we try to change our business to suit the software, because maybe the software does not really fit what we do here in our company. Because we bought it. But if someone's going to create the software for your business, they have to understand and appreciate how your business operates, and then create a software which relates to your business. And when they are doing that, when they design the database, the data diagrams should reflect understanding of the business processes. So for a person who is doing this, they have to look at business documents, they have to interview employees, and just having professional experience help in this respect. So the following steps in conducting analysis of a business situation in order to create a database. You have to identify entities, you have to identify relationships, you have to draw a rough diagram, You have to define primary keys. You have to identify attributes. You have to map attributes into entities. You have to add foreign keys. You have to draw a fully attributed diagram, and you have to check your results. So let's go ahead and see how it's done. So, for example, a customer in a shop which is called Big Buy places orders with the store. An order contains products. The important data for this are customers' first name, middle name, last name, street address, city, province, postal code, and phone numbers. Also need the product name, unit price, order date, and the quantity of product ordered. All right, because the customer here is going to place orders to buy something. Now, let's identify entities. So mark those words that you think may correspond to entities in the data diagram you want to draw. For example, a customer places orders with the store. So here you can actually see that you can have an entity customer and an entity order. The order contains products. So you can actually also have an entity of products. And here the store is not thought of as an entity. The store is location of sales operations or the subject that records this operation. As such, the store is not a data entry entity to be represented in any information system. Now, identify a relationship between the entities. So in our entities, we have, in our example, we have minimally two relationships, which we said a customer places an order, and an order contains products. So it is a custom to read relationships from left to right and from top to bottom. Sometimes you may need to arrange entities so that this order is supported. If this is not possible, an arrowhead can be used to guide the reader. All right? So an arrowhead, what to draw arrow is show then you actually. So if you have a customer and a purchasing history, you can actually have an arrow coming from purchasing history to the customer. So this purchasing history applies to this customer. So we can create a rough diagram where we can say, okay, entity customer who places an order which contains products. Then define primary keys. A primary key is an attribute or a group of attributes that can be used to uniquely identify a specific instance of an entity. The name Bob Smith cannot be primary key, as there are many people with that name. So whole numbers are better to use for primary keys because each number is unique. In this example, the keys are customer ID, product ID, and order number. So the simplest way of naming a key is by taking the entity name and adding ID, short of identification to it. So customer ID, order number, product ID. And we can now start defining other attributes for each and every one of those entities. So you have to try to identify and name all attributes essential to the business you are studying without trying to match them to particular entities. So you can just throw them in. So the best way to do is by studying forms, files, and reports currently available and taking a note of each potential attribute. Because we know that usually people have got forms which they fill in a business. So you can take that form, try to check and study them and see which of that information can actually be attributes. So you can cross out irrelevant items such as signatures and data that repeats, for example, company name and address. So if so indicated, cross out any attributes that are no longer used or will not be used in future. And then the remaining items should represent the attributes you need. So the attributes indicated in our case are the customer first name, customer middle name, customer last name, street address, city, province, postal code, product name, unit price, quantity in stock, order date, and quantity of product ordered. Then map these attributes to each entity. So for each entity, you need to match it with exactly one entity. Often it seems like an attribute should go with more than one entity. For example, name. In this case, you need to add a modifier to the attribute name to make it unique. So you cannot just say name. You can actually need to say customer name or product name. So when an attribute may belong to different entities, the rule of thumb is to determine which entity an attribute describes best. For example, the attribute unit price logically belongs to the entity product rather than what? The order. Then from there, you can now start adding foreign keys. So foreign keys are not genuine attributes, but are added to support associations in a relational database. So you want to see if you want to associate one entity to the next, you can now put a foreign key. So a foreign key is created by reading a relationship from a source, e.g. customer, to a destination which is in order, then exporting the foreign key from the source to the destination. So the one which was primary key now becomes what? A foreign key. In this example, we have the primary key named customer ID in the entity customer. It becomes the foreign key named customer ID in the entity order. In contrast to primary key, the foreign key is not marked, so it looks like any other attribute. Remember, I said the primary key, you have to underline it. The foreign key, you don't underline it. We recognize that an attribute is a foreign key by following the association line, starting from the primary key, then looking at the attribute in another entity where the line ends. Also, a repeated name of a primary key in another entity indicates a what? A foreign key. Then from there, draw a fully attributed data diagram, which we call a schema. So if you have attributes leftovers without corresponding entities, you may have missed an entity or its corresponding relationship. Identify these and add them to your list. In our example, there's just one such odd attribute, the quantity of products being ordered, quantity ordered. This attribute does not really belong to the either product or order, but to both, to a product that is on order. So this is what we call a bridge entity, technically called association entity, because it belongs to the association between two entities rather than to any of them. So an association entity is represented in a separate table. So in our example here, the association entity is called order detail, which contains the attribute quantity ordered. You see the diagram below. Therefore, one order can contain 1 kg of apples, 1 kg of oranges, which are represented by their product ID. Another order contains 2 kgs and so forth. Notice that an order can have one or more products. Also, the same products appear on different orders. So this possibility shows another purpose of association entity to interface the entities that both have the multiplicity of many, like product and order. So here we've got a table here showing us entities. You have entity name or type. So you have a customer, order, product, and order detail. All right. And on the attribute side, the primary key, we have to identify the primary key for each and every one of these entities. Customer, the primary key should be customer ID. Order, the primary key should be an order number. The product should be product ID. But order detail, it combines keys of associated entities, the order number and product ID. Because you cannot have an order detail number. You can actually have the relationship between order number and product ID to come up with the order details. Then for foreign keys, for customer entity, there is no foreign key. But on order, we can actually have customer ID because we want to know who's the customer who ordered something. On a product, there is no foreign key. But order details, we have your order number and product ID because now we have details. These are details now of the order which was placed. Other attributes for customer are the information for customer here. And other attributes for the order can actually be order date. Other attribute for product should be product name and unit price. Can ribadza rate $5, right? But the primary key, we have to give it a number, which is the product ID. And the other attribute for order details can actually be quantity ordered. So if we have all these things, now we can actually be able to proceed. An association entity is actually a special case of an entity with some unusual characteristics because it does not stand on its own. Sometimes it's difficult to actually see, but when you see that there's an attribute and you can't really place it somewhere else, you have to think of an association entity, which is an entity between two entities. All right. Now we go ahead now and start drawing our diagram. The diagram in figure 5 here, it shows entities that, technically speaking, are implemented in tables as they appear in a relational database. So here we've got now your entity customer and its primary key and its attributes. And we have an entity order with order number being its primary key order date and customer ID. This is an entity. And we are saying there's a relationship between a customer and an order. Because we're saying a customer can place many orders. And the multiplicity is that we have one customer can actually place many orders. Then we have a product. The product, you have got product ID, product name, unit price. Now we have another relationship entity which is actually going to give us order details, which is the primary key. Now is a combination of the order number and the product ID. Here we want to know how much was ordered, right? Because we have an order number, customer, who is the customer, what is the date, but now what product was ordered, what is the order number, how many were ordered. So we actually have one product, actually have in one product in many order details, and one order having many order details. So at last you have to check your diagram to see if it makes sense. So this is the final check. So this is what we want you to go through when you create a schema for a database. You go through these processes. So in summary, we're saying data analysis represents a part of business, such as a business process with concepts of data entities, attributes belonging to an entity, and associations between entities. We use nouns to talk about entities and verbs to indicate associations. Although attributes are also indicated by nouns, an attribute is part of an entity. It cannot stand on its own. Special attributes are primary keys and foreign keys. Primary keys uniquely identifies each instance of an entity, and the foreign key is an attribute that is a primary key in another table, and it is used to establish associations between entities implemented in a relational database. And two tables get associated via the primary key foreign key connection. Okay. A special sort of entity is called an association entity. It results from a relationship between two entities, and so it does not have a primary key on its own. Rather, it combines the foreign keys that reference the associated tables to create the primary key. The role of an association entity is to store attributes that do not belong to either of the associated entities, but to their relationship. These attributes may vary whenever those entities get associated. In a relational database, entities are implemented as tables. A diagram of tables along with the attributes and associations is called a schema. So everything that applies to entities applies to tables as well. Any questions, comrades? Talk to me. Jenna.
Thank you very much, Doc, for a marathon lecture. That I feel there's quite a lot of practice that is needed, especially when you mentioned the issue of creating a schema or a database. I just got some interest, and then I just thought, no, maybe there's need for some practice to have specific scenarios that we can work on.
Yes, you are very right, Jenna. I'm going to give you the notes. As I said, I'm going to share with you the notes so that you repeat what I've been saying. And then you can also practice on your own. You identify a business process and you say, I want to create a schema for this. You know, when I was talking to my Johnny previously, we just took an example of examination process, isn't it? So you can take, you can look at your work and say, at my work, this is the data sometimes, which these are processes we work with. If we are going to create a schema, which are the entities, and for each entity, what is its primary key, and what are its attributes. Like Jenna, can you give me an example? Where do you work?
I'm a teacher at a school called St. Dominic's Shawasha.
Okay, right, that's good. Now, you can actually have, let's say, we want to take the examination process for teachers, isn't it? For kids. Then we know that we have reports, isn't it? We have school reports. In a school report, maybe you have students, you have your students, the name, the address, date of birth, things like that. Then we have subjects, as a subject, English, maths, and so forth. Then eventually you have marks obtained in each of those. So you can actually start thinking of, how can I put this in a database, right? So the student is an entity. We can actually have a student ID as the primary key. And then the attributes of a student, you can actually identify them as student name, a surname, address, phone number, or contact of parent, things like that. Then subjects, you can actually give these subjects a subject ID, then a subject name. Even the subject, you can even give it a subject teacher if it's important to you. Right? Just like the way we did with the orders, right? So we had a student, a course, and the results. We had a customer, and order details. How together?
Following, Doc.
So you can sit down and now try to experiment on your own and come up with your own schema, the way we did with the one with customer and order. Right? Try many other business processes, like even the pharmacy one, where you actually buying medicines, where someone comes in with a what do you call it, prescription, things like that, and you have products which you want to sell on a prescription and so forth. They have prices, things like that. Play around. If you go on the internet, you can even search for, generally, you can even say a schema for a pharmacy or a clinic or things like that, and see unfortunately, maybe mostly you see the diagram of the final thing, but you can see where they came from, isn't it? And try to trace it back. Mapurisa, I want to say something. Any other questions, guys?
How are you, Doc? Can you hear me?
Yes, I can hear you.
Thank you. My name is Mapurisa. How are you, colleagues? Yeah, Doc, I was following. Then I was just asking myself, I was trying to identify what kind of question can come up from this in an examination. I was just hoping that I won't be asked to come up with an SQL. But I was just trying to think what kind of questions that can come up from the presentation that we covered today.
Okay. Thank you very much for the question. As a student, of course, it actually shows that we are in this course just to pass.
Yeah, I think that's the primary objective, and then the application in real life comes later. But the immediate objective, of course, is to pass the examination so that we can then later on apply what we'll have learned in practice. But the immediate and pressing objective is passing the examination. I think that's very true.
Okay.
You forgot to say it's the primary key.
Yeah, that's the primary key, Doc.
All right. Thank you very much, guys. Lloyd.
Yes, Doc.
What basically, usually, I would just ask you to say, I'll give you a scenario to go ahead and design a schema for me. I'm not going to give you something which is extremely difficult. But the reason why we are learning this is that you are the business guys and you are doing MBA, executive, we call it what? Business leadership. So we expect that you are going to be managers. You are doing this because you want to become managers wherever you're working, whether maybe you have your company or you are working somewhere you want to be promoted to become a manager. That's why you're doing this course. And at some point you want to have an information system or a software which is used every day in your company. You may develop it in-house or bring someone from outside. And that person comes, as I said in my slides there, that person comes and they interview you so that they can come up with a software which relates to what you want to do. Now, if you understand, you have an appreciation of what is an entity and what is an attribute. The way you discuss with people who are going to design your software is going to be different from someone who has never heard anything about these things, right? Because you are going to say the attributes which we are mostly concerned about in this company, which we are going to use in our reports, are the customer and the orders. All right? We want to see, at the end of the day, we want to see in our reports which customers placed which orders and what did they order. You're not going to concentrate on other things which don't pertain to the business. Because someone who is going to create the software can concentrate on the employees. But you're concerned about the money issue. So you're directing the person through the business processes. All right. So you don't want to say the system has been created and you say, it will be better if you understand this concept and appreciate, and you can direct them on what you want them to do. How to get it? So we are doing this not just to pass the exam, Lloyd.
Oh, yes, Doc.
We want you to become a better manager.
Yeah, correct. Yeah, because you know, as we were going through, you actually become you know, you kind of open up. You know, you start seeing things differently.
Yes. So this issue, when people acquire software, there is a lot of responsibility to management. Management has to appreciate what they want, not to leave it to the IT guys. So if your company creates a Edgar's, the IT guy thinks software, they want to program, they want to do this, and so they are not worried about business processes. But you are the business guy, you are going to direct them. No, my guy, these are the entities I'm worried about. And in each entity, don't worry about these other attributes. The only attributes I want are 1, 2, 3 all together. And the person, you are directing them to the right thing. So the lesson I gave you is not too difficult. Even if you can even search on Google now, you know the terms which I'm more worried about: entities, attributes, schema, isn't it? So I can even search them and learn how to link them in a diagram. You can actually be able to draw the diagram on your own and give it to the IT guy that this is the diagram of my business processes. Of course, he can help you going forward from there. But if you know your your foundation, then you are up and running. All together.
So, thank you, Doc.
Yes.
Yeah, what I have discovered this is really more interesting. Why? Because the way you articulated these issues step by step, I can visualize and see that these are the things we are facing every day. This is part of our life we are doing. We are doing these things, but maybe not really knowing, this is a schema, this is an attribute, this is, but I think this is more practical. We face these issues every day. Maybe what we just need is go revisit and be in a position to create these schemas. I think that becomes easier for us, and as we prepare for our examinations and our real life situations. And for example, surely you might need maybe to build, or maybe you outsource other people to come and build software you want to use in your organization. You need to have more familiarity with these issues, so that at least you provide them with the kind of system you would want them to develop for you. Thank you.
Thank you very much. Any other contribution, guys, before I continue? I'm sorry that it's going to be, it's been a marathon because looking at the timetable, I think we have, is it 4 or 5 lectures only, because it's done, isn't it? So every time we meet, we have to go through a marathon, or it's either maybe I will go through the video on my own, then I post it for you. Then the next time we meet, we discuss my video.
I'm sure that way it works, especially that some of these issues are technical.
Okay.
That way to do well.
Do we have ladies in this group? Base chat. Irene, how are you?
Fine, thanks, Doc, and yourself?
I'm great. Unofana uchimbotaurawo vanokuteerera vari mavo. All right. Okay, guys. The next lecture I'm going to do is short. This I'm not going to this. I think it just have 11 slides, so it's short, and we are done for today. Then I'll share the content with you, and then you can prepare for the next lecture for over the next weeks. And if possible, I can do a video and then share again, and then we can discuss on WhatsApp, isn't it?
Yeah, I think that's okay, Doc. Our slots are very few, but the content requires a lot of attention. So sometimes I feel when we have a lecture on a weekend like this, during the week, you can record a video, you post it on WhatsApp, you give us time to digest it, and then we have a conversation over that way. That would be quite grateful.
Okay, thank you very much. I think we'll try that. It should work. Now we want to do more on data analysis. Here we want to be analyzing data in different business domains, differentiating entities and attributes, analyzing associations between entities, and talking about data quality standards. Here, this is a schema for procurement or supplies. Okay. Business starts on the supply side. So the companies procure or gets inputs they need for producing goods or services. Manufacturing companies purchase raw materials and half products to produce a final product, which is a good. In a bank, lenders supply financial resources that the bank uses for offering financial services for bank clients. In manufacturing, purchased items and purchasing orders are key entities and tables in a schema. Product is ordered from a supplier via purchasing order, a business document. So a purchasing order is a business document. The entire process is usually supported by a transaction processing system. So if we look at our schema there, we're not going to go through the production of the schema, but we're just looking at it. You can actually see that the person who drew the schema identified 4 entities. Actually identified supplier, purchasing order, then purchased item, which is an item. Then you can actually see now that from the purchasing order, there is purchasing order detail, which is we gave it a name. What is the name of that entity? A relationship entity, isn't it?
Oh, yes.
So, because there's a relationship between a purchasing order and the purchased item, where you actually have to give more details there. So, it becomes the 4th entity. And under supplier ID is the primary key. Under purchasing order, purchase order number is the primary key. Under purchased item ID is the what? The primary key. But on the purchase order details, this one there's no primary key. The key is a combination between the primary key of purchase order number and purchased item ID. All right. So this is a simplified procurement or supplies schema. If we go ahead and look for another example, this is a production schema for production scheduling process. You want to produce something in industry. Usually, you have a task and some workers. We want to do that task. So the task is an entity, and the workers or the worker is an entity, right? So under task, you can actually give a task an ID, right? And then its attributes, which is the task name, description, time required to finish it, and things like that. Then the workers, which are employees, we have the worker ID, the names, the department, position, specialty, and so forth. So now when you link the task and the worker, you can actually come up with the schedule, all right? Which you actually give a schedule number, all right? Now the schedule, each schedule, now we're saying this schedule, we're going to give it, it's for this task, and who is the worker we've asked to work on this schedule. Then we put the worker ID, then the date, want the work to be done, the shift, want the work to be done, and things like that. So you see, they actually here, there are actually 3 entities. Please don't confuse schedule. Schedule is not a relationship entity. All right, it's a process, isn't it? It's a process entity because it's actually giving us a schedule, a task. Pada ucherwa mugero apo. Mugero wasitowacherwa, vashandi vanochera ndanani, list tinayo under worker. Now we're saying, can we draft a schedule or schedules to do these jobs? Apada ucherwa mugero, apada kugadzirwa magetsi, apada kuitwa zvakati. So these are schedules to do different tasks. So we actually have a table for schedules, and we allocate, when you allocate workers to the schedule, you see the worker ID there is a secondary key or a foreign key, isn't it? A task ID, the task of the work which we want to be done in each schedule comes in as a foreign key there. So this is a simplified schema for production scheduling process. You can even Google this up. You can actually see maybe another one which is even more complex, right? So as my friend was asking, what type of question this guy ask? So he was troubling himself. So I can actually come up and say, can you come up with a schema for a procurement process? So I can actually have to start explaining the process first in words so that you can actually be able to identify these entities, the attributes, and the relationships, right? So that you can actually at the end, so in the process, I will actually have to, when I'm marking, I have to follow, see you actually identifying attributes, drawing your diagrams, and identifies primary keys and so forth, and eventually your diagram will be out there. Okay. This is an HR schema Of course, this is also simplified. Can't say this is enough for HR. But the key tables are salary and wage. Salary is fixed, wage is variable. Note multiple foreign keys in salary and in wage. So which means here we have in a HR schema, you have entities, of course, the employees, because my employees are the ones who are going to be paid, isn't it? And salaries, because people are going to be paid. And can someone tell me the difference between salary and wage?
Hello, sir.
Yes.
I can attempt, sir.
Go ahead, sir.
Right, I don't come from HR, but from what I think, okay, one of them we have already explained that the other one is fixed and the other one is actually not fixed. Also, you also notice that we talk of salaries for people that are usually permanent employees to an organization, and we also talk of wages to mostly casual workers. So basically, that is what we normally have. I think, yeah, that should differentiate those two, I think.
Okay. Thank you very much for clarifying that.
Doc, the other differences could be on the frequency of payment. You'd find that wages in most cases are paid more frequently, like usual on a weekly basis, salary on a monthly basis, and wages also usually apply to the productive hands, and they usually vary. What makes it variable is the time that the people take to, you know, when they log in and what have you, so that a person is paid for the time they've spent on the job.
All right. Okay, thank you very much. So this is an example of a schema for HR. What I encourage you to do is you can Google it and get even a more complex one and study it. Okay. So which means if you, I hope I will share with you some lessons for my past exams so you can appreciate what kind of questions I asked. Okay. But basically, I would just want you to create a schema, but you can't just draw it like that. You have to show me where it's coming from, isn't it? This one is an accounting schema. Most of you guys are accountants, aren't you? You did account somewhere, but in and numbered accounts. So I can't explain this one very well. But basically, account tracks money value of all tangible things on the inflow, revenue, and outflow cost side. These two objects translate into revenue and cost entities or accounts. There can be many of each. So account is the key entity. So the account is the key entity or table. So we have account receivable, account payable. So here we have different kinds of accounts with their IDs and so forth, names, organization. So what I would want you to do is actually go and get the bigger, because this is just, as you can see from 4A and 4B, these are partial schemas for an account receivable and account payable. Can you go out there and get a full schema and try to see how it was created? You never know, since you guys said Zama is very important.
Yeah, in a way.
Then this one is a marketing schema. And I know that most of you guys did marketing. So marketing processes create and manage markets, to understand markets. Companies segment markets based on planned amounts of customer purchases, whether low or high. And customer spend is the key entity. So which means you want to identify your markets. So customer spend is an attribute about attribute spend amount, which shows the purchase total per customer in a period of time. So you want to know that this customer, you can actually maybe group your customers according to the amount they spend, so that when you market, you can actually target them differently. So customer spend can actually be an important entity there. Then you have market segment and a purchase. So you can actually have those primary keys in each and every one of those entities. And as we said, this is a partial schema. I would encourage you to go and look for the full schema. Because of course, in an examination, if I say go and create a marketing schema for me, I'm not looking for a partial one. I'm looking for something which is close to the full schema, isn't it? Because sometimes I can actually say full schema, 20 marks, isn't it? So you have to actually go and dig deeper. All right, identify which are the attributes, which are the entities, all the entities which I may want in this marketing schema, and what are the attributes for each of all those entities. What are the relationships between those entities? Then you go about and draw your scheme. Then you get your 20 marks. And that's a lot of marks in an examination, isn't it? Since you guys all right, guys. And this one is for a library. We all know about the library. So you see the schema for a library where you have so is it saying don't get scared? Eh? This is how a data diagram for circulating library materials may look like. Focus on the key tables and their relationships. So if a book title, you can actually have a book title, as an entity, book copy, as an entity, a loan, library patron. Library patron is the person who is actually going to get a book in the library. Reservation, book copy on loan, then there you can actually have different types of patrons there as entities. Maybe because they have different types of attributes for each. Because if it's a faculty patron, that's a lecturer, a graduate student, a master's or PhD student, they have their own attributes. Can you accept that person, please? Then you have an undergraduate student.
Done.
Can you come again? So under reservation, what primary key can we put there? You can actually have a reservation ID. Library patron, you can actually have library patron number. I remember long back, people would get library cards, isn't it? In each library card, we have a number to identify the person. So you can actually have a number, identify the patron there. Okay. And the book title, you can actually have an ID for the title. The copy number, you can actually have a copy. Each copy of a book is actually, you can actually give it a number for each copy, and so forth. And e-commerce. This one is for an online store. Of course, this is also simplified where you have your customer and catalog search, comparable customer, page visit. So you want to actually profiling. This one is actually for profiling customers. You want to see who actually searched or visited our website, what did they watch, how much time did they spend on our page, what did they buy if they eventually bought something. So that when you actually start targeting people for advertisement, you can actually target people with relevant information. Have you ever seen that once you access something, sometimes you start seeing adverts around that something you've searched for, isn't it? It means a certain website has profiled you that you like this. If you start searching for scholarships, all of a sudden you start seeing adverts. Every time you open a web page, you go on YouTube, you see adverts for scholarship. You go here, you see adverts for scholarship. It means someone has profiled you that this person looked for scholarships and they may want to see this scholarship. If you bought clothes, you may actually see that when you open your websites and so forth with the Google adverts, you are targeted with clothes adverts. So that's customer profiling. So this one is actually a schema for marketing, for profiling a customer. Now, when data is being entered in a computer, there's supposed to be some standard, or people have to pay particular attention to relevance of the data. You don't want to just keep data which is useless, and data which is consistent in a database. Non-redundancy. You don't want to have tables with too many information which is the same. So you don't want to say someone comes at your website, they enter their information. When they want to buy, you ask them to enter their information again. That's redundancy. So you want to remove all those things when you create tables and so forth. The data should be accurate and complete, and data should have timeliness. And it's important not to neglect these things. So if you input bad data in a system, you expect to get bad results. So when someone is designing the database, and if they are not paying particular attention to what we have been doing, they can actually end up with a bad result, a bad software. Have you ever heard the morning giggle, garbage in, garbage out? So you want your data to be smart. So in short, in summary, we talked about a schema. A schema is a data diagram in an area, in any area of business, usually has some key entities which eventually becomes a table. You have to pay attention to associations between tables. You have to A, analyze carefully a business situation, and B, implement each association as a link between primary key and the foreign key. And meeting standards of data, relevance, consistency, non-redundancy, accuracy, completeness, and timeliness ensures appropriate informing. So thank you very much, ladies and gentlemen. Any questions so far before we close this session? Merek unonzani? Who is Merek?
That's me, Doc.
Yes, how are you?
I'm very well. My name is Michael Merek.
Michael Merek, unonzwa Merek ndekwako ere?
I'm actually the CEO.
That's great.
Do you have an order?
Wotendesa kase class patopedza course.
Do you have some orders?
All right, we'll make some orders. Any questions?
As of now, Doc, the issue is it's more of I'm still taking in.
Yes.
But questions they are going to come definitely. But as of now, it's still kind of you are still opening our minds. We are sort of confused in a way, but we are getting some of the stuff.
All right.
Yeah.
Thank you, guys. What I will do, I will download this video for you of this lecture, and I'll see how I can share it with you, because I think it's very long. It's almost 2 hours or more. It's actually 3 hours, 10 minutes. So you will have to go through it if you want to revise what we've done, and looking at our notes and see if you have any questions, then you can talk on WhatsApp. I'll give you an assignment to cover all the work we've done today. When we meet next time, we'll cover business processes. And we'll give you an assignment that covers business processes and so forth.
Thank you very much, Doc, for an insightful lecture. Maybe on behalf of the class, maybe our request will be, if it's very possible with you, and if you are comfortable, for the next lecture we are going to have, if you can also post the materials to us, so that in advance we also have an overview of it, so that when we meet, at least we will not be blank, will not be empty slates. Will be moving in tandem with you. And maybe secondly, this is our foundation, and we are starting it. We want to start at a higher note. If it's also possible, if you have got some past examination papers, maybe you can also post them to us, so that when we are also studying and reading, we are also focused. Otherwise, I think you did justice for us today. Thank you very much, sir.
Thank you very much, Mr. Majoni. I'll post a link to my Google Drive, and I'll share with you my drive. I think most of you have given me your emails, so I'll share with you a link where I'll dump most of this information. I think I have it already there, so I'll just share it with you so that you can access it. Okay, if nothing else, thank you very much, ladies and gentlemen. I'll see you next time.
It has been a pleasure, Doc.
Thank you, Doc.
Thank you.
Thank you, Doc.
Thank you so much.
Thank you, Doc, for the lecture.